In this video, we will learn how to decompose the price factor into substitution factor, income factor, and endowment factor with an example. This question was asked in Indian Economics Service paper of 2022, I guess. The question was, a farmer grows 70 kg of good X1 and 20 kg of good X2. Okay, he keeps some part of X1 and X2 for self-consumption and sells the rest in the market. Also, his utility function is, that is, utility is a function of the two goods X1 and X2, which is equal to minimum of 2x1 comma x2. So we have a perfect complementary utility function here, and the prices of good X1 and X2 are being given us as $2 and $3 respectively. Then we are being told that suppose the price of good X1 increases to $4 and at the same time his consumption of X1 also increases. Okay, here you can see price of X1 has increased, with that consumption has also increased. So it seems like a peculiar situation here. Let us learn how this happens. We have to explain the behavior of the farmer using substitution effect, income effect, and endowment effect. Okay, so basically here you can see income of the consumer is not being given. Income is in fact the endogenous variable here. Okay, income is not given us in the fashion that the income of the farmer was, let us say, $2,000. It is not the case here. Income of the consumer will be the endowment prices here. Okay, so endowment is here in fact the income of the consumer, which is endogenous. So what we are being given, utility function, that is min function, which is equal to 2x1 comma x2. Endowment of good X1 is 70 kg and endowment of good X2 is 20 kg. Price of good 1 is 2, price of good 2 is 3, and price of 1, that is X1, has increased to 4. Okay, so how do we solve this question? First we need to find out the initial consumption bundle, that is at initial income, okay, without the price change, how much will consumer demand of the quantity. So what we have the situation here, we have to maximize this utility function of the consumer subject to the budget constraint. What will be the total endowment income of the consumer here? As I told you, income is endogenous here. That means consumer's income will be equal to price of X1 times the endowment of X1. Endowment is 70 kg, so 2 into 70 plus price of X2 times the endowment of good X2, that is endowment of good X2 is here 20. So when we multiply these, we get the initial income of the consumer is $200. Okay, so initially what we need to do, we need to maximize the utility or the satisfaction of the consumer. So for maximization, what we do, we use this, that is, we want to maximize this utility subject to the initial budget constraint here. So initial budget line, I have drawn it here, AB. Okay, on this budget line we need to maximize the satisfaction of the consumer. Okay, so we want to maximize the utility subject to the initial budget constraint, that is 2x1 2, the price of good X1 plus 3 price of good X2 should be equal to 200. Okay, so using this near case so we get 200. This is our budget constraint, so we want to draw an indifference curve. As we know, in case of maximization, what happens, this is our indifference curve, this is our budget line, and at this budget line we have a L-shaped indifference curve because we are dealing with the perfect complementary utility function. The indifference curve is L-shaped. So initially with this red budget line, consumer consumes, we need to find out the optimality condition. As we know, in case of the main utility function, how do we solve? So simple thing is, for optimality we equate whatever is in the brackets. Okay, in the brackets we have 2x1, we equate it with x2. Okay, now we use this value of x2 and plug it into the initial, and here we plug the value of x2. Okay, After that, when we plug the value of x2, we get x1 is equal to 25 and x2 will be equal to 50. So initially he will consume 25 units of good x2 and 50 units of 25 units of good x1 and 50 units of good x2. Okay, having said that, this is our initial budget line. Now after that, what happens? Price of good x1 increases. When the price of good x1 increases, okay, if price of the good x1 increases, consumer will consume less of x1. Okay, that means when price of good one has increased, we have to find out the pivoted budget line, that is AB. So when price has increased, the quantity of good x1 will decrease, the quantity of good x1 demanded will decrease. So new budget line will be this AB prime. That is our new budget line, what we call pivoted budget line. It will be a function of new price of x1, x2 is same, and income of the consumer we held it same. That is our nominal income. Then with this new budget line, we want to again maximize the utility subject to the new budget line. Okay, so this is our new budget line, maximizing the utility. At this point we will get, again using the condition what we use in the optimality of the perfect substitute utility function, we equate x2 with 2x1. When we solve this, we get x1 prime is equal to 20 and x2 prime is equal to 40. That means when the price of good x1 has decreased, consumer will consume 20 units of good x1. Okay, simple fact, there is no I guess rocket science in this. So this was our pivoted budget line. After that, we need to find out how much income do we need to give to the, how much extra income do we need to give to the consumer, so that the initial bundle is just affordable at new prices. Okay, that is how much income we are supposed to give to the consumer, such that he is able to purchase the initial bundle. Okay, so the change in income will be equal to change in the prices of good x1 times units of good x1 that he was initially consuming, that is 25. That is change in the prices is from 2 to 4, so change in price is 2 times the units of good x1 he was initially consuming 25, that comes out to be 50. That means we need to give the consumer extra $50. Okay, so new income will be equal to old income plus the extra income that we find out using the cost difference method here. So this is, it is initial income, this is the extra income that we need to give to the consumer. So new income will be equal to 250. Now we need to find out the shifted budget line, okay, which I have denoted by CD here. Okay, so again we have to use the maximizing condition in case of perfectly complementary utility function. What we do, we equate whatever is in the brackets. So x2 is equal to 2x1. I have explained the perfect complementary, what we also call the Leontief utility function, in earlier video. Do check out those very videos on this channel. Okay, so shifted budget line will be equal to CD, and we want to maximize the utility with new prices and new income. New income is 250. That is, we want to maximize the utility function, that this main function subject to the new budget constraint. Okay, again equating x2 with 2x1, we will get x1 double prime is equal to 25, x2 double prime will be equal to 50. That means when we shift this budget line, consumer is again on the same point where he was initially. Okay, what happens then? Why are we getting at this point again? It is only because in case of a perfect complementary utility function, we consume the goods in a fixed proportion. Okay, so there will be no substitution effect. If our new independence curve was like at this point, then we could have said that the initial the shifted budget line has what I can say, the shifted budget line has passed through the initial budget line and then this would have been our a new optimal point, but it is not the case. The new budget line, this shifted budget line and the initial budget line, the two indifference curves will coincide with each other because there is no substitution effect in case of the perfectly complementary utility function in case when we have the goods when we consume them in fixed proportion. Okay, so going from CD, again we are getting the same indifference curve and optimality happens at this point. Now what is the substitution effect? The substitution effect in this case is, initially we were at x, that is at this point, that is x1 double prime is equal to, we have written somewhere, that's 25 minus we do the x1, which is again 25 minus 25, because we are in back to the same point again, so there will be zero substitution effect here. Okay, so I hope I make myself clear. Now we need to find out the income effect. Okay, to find out the income effect, since when the price of good 1 has increased, quantity demanded of good x1 has decreased, so the movement from this point to this point in fact denotes our income effect, which is equal to 20, that is x1 prime minus x1, which is equal to 20 minus 25, which is equal to minus 25, minus 5. That means with the increase in the price of good x1, consumer will decrease 5 units of good x1 as quantity demanded. Okay, this is our income effect. Now what about the endowment income effect? So as you know, prices of good x1 has increased, that means the endowment income of the consumer has increased. Okay, so endowment effect will be equal to, that is the change in income will be equal to change in the price, that is 4 minus 2 times the initial value of the endowment, that is W1, that is 2 into 70, which is equal to 140. That means consumer is getting 140 extra dollars this time with the change in the prices of the endowment. Now what will be the new budget, new income of the consumer, new endowment income? That will be equal to the initial, initial income plus the change in the income. So initially he was having $200 plus the change in the endowment income, which is 140. So new income will be equal to 200, rather it is $340 here. Okay, now with the change in the endowment income, we need to find out the final budget line, that is the endowment. To find out the endowment effect, we need to find out the new budget line, which will be equal to the change in the price of good x. That will be a function of the new prices and the new income, that is the endowment income. So we want to again maximize the utility function, utility of the consumer subject to the new endowment budget line. So we have again using the optimality condition, x2 equal to 2x1, solving we get x1 triple prime is equal to 34. So this budget line has shifted. This is our endowment budget line here. Okay, so we will be finally at this point. Okay, while consumer will consume 34 units of good x1 and 68 units of good x2. Now what is the endowment effect here? So I have written here endowment effect will be equal to, that is x1 prime. So the finally we are at this point, which is x1 triple prime minus x1 prime. This, the movement from B to D, in fact denotes our endowment effect. Now what is the price effect, which is equal to substitution effect plus income effect plus endowment income effect. Okay, substitution effect is 0 because we are dealing with a perfectly complementary utility function. We use the goods in the fixed proportion. Income effect is -5 because the change in the price of good x1 has decreased our quantity of good x1 by 5 units, plus the endowment effect. Okay, what is endowment effect? I have told you we are at this point from B to D denotes our endowment effect, which comes out to be 14. Okay, so the price effective will be equal to 9. Okay, let me be very precise here. Initially we were at this point A, okay, with initial budget line. Then price of good X1 is increased. With that, this budget line will pivot to the left. Okay, so we are at point B where we are consuming 20 units of good X1. Okay, after that we give the extra income to the consumer so that the initial bundle is just affordable to the consumer. So this line shifts again here, and we are back on the same indifference curve, that is IC2. Here IC1 is equal to IC3. Okay, the movement from A to C, which is here 0, that denotes our substitution effect, and the movement from C to B denotes our what we call the income effect, which is equal to 20 minus 25, and the movement from B to D is equal to 14, which denotes our endowment effect. I hope I make myself clear in this video. Thank you.